Okay, I want to give you the solutions to some of these quick tests. So on a circuit breaker, you have these devices. And then I add this device, the television, and then the circuit breaker turns off. I want to assume all devices operate at a voltage of 120 volts. What is these as the maximum allowed current for the breaker? So first of all, a circuit breaker turns off when you exceed a certain current. For most houses, that's 15 or 20 or 30 amps. But in this case, it's not necessarily any set value. So the first thing I do is just figure out what is the current in each of these devices. I know that current is power over voltage. And so for example, for that first one, it's going to be 1200 watts divided by 120 volts. That's 10 amps. So I have 10 amps here, 1 amp here, and 1 amp here. So everything's functioning just fine with 12 amps. And then I add the television, which is 480 watts. That adds an additional 4 amps. So somewhere between 12 and 16 amps, this circuit breaker is going to kick off. And so I look for a number that's between 12 and 16. That means that this circuit breaker is a 15 amp circuit breaker, which is kind of standard actually, but on the test, don't expect it to be standard. Or it could be too. I don't know. Just know how to do it, and then it makes life a whole lot easier. The third prong on electrical outlets provide which of these? The third prong on electrical outlets provides an alternate ground. Okay, it's not a current measuring device. That would be a GFCI, actually. That is a device that measures current. It's not an emergency switch. That would actually be a circuit breaker. It's a switch that turns off in an emergency when your current is exceeding, or that could also be a GFCI too. That's also an emergency switch. It's just sort of the criterion is different. More stability, that's not really a thing. What does a GFCI do? Okay, GFCI does not do this or this or this. GFCI does this. Students often confuse GFCI and circuit breakers. This is a circuit breaker. Circuit breaker kicks off, turns off, if you have too much current. The GFCI doesn't look for the amount of current. The GFCI only looks for a difference in current. If your current coming in and your current going out are different, that's bad. That means that you have current going somewhere where it's not supposed to be going, which usually means it's going into you. And so the GFCI checks for a difference between two different currents. Which of these statements about household circuits is true? The household circuit is a parallel circuit? Yep, that's right. All devices in a house operate at the same current? Nah, they can operate at different currents, like your bathroom heater operates at a much higher current than your computer, for example. As you add more devices to a household circuit, potential across each device decreases. Is that true for parallel circuits? Nope. As you add devices, they always have the same voltage. It's just the total current's going to increase. And the circuit breaker turns off if IN is greater than I out. That's not true. It would be true if it said GFCI, but that's not what it says. So 1 only is the answer. All right, I think that's the end for our chapter 5. Chapter 4. I'm going to make a new one for chapter 5.